All right, lesson 1.8, applying exponent rules. So, you guys have actually done some of these exponent rules in Math 9. Do you remember, let's say, if you had 3 to the power of 2 times 3 to the power of 4, that would be 3 to the power of what? 6. Good, you guys remember that. So what did you do there, right? If they had the same bases, you add the exponents. So that was 6, right? Okay, well, that's what our first exponent law is. It's the power, or the product of powers. And it's written a little different, but you see that it's x to the power of m times x to the power of n is equal to x to the power of m plus n. And I know it can be a little bit confusing with like the variables in there instead of like the numbers, but it's saying the same thing, right? X to the power of m, in that case, m would be like 2, like just any number. X to the power of n would be like x, like 3, right? Same base. To the power of some other number, n, is the same thing as x to the power of, and then we could have written that as 2 plus 4, or, sorry, 3 to the power of 2 plus 4, or 3 to the power of 6, right? So we have to be kind of, start getting used to seeing some of these laws or some of these rules. They're always written in a general form with variables. As you go through all the different grades, especially more advanced math, we do quite a lot of this, especially if you go into university. Okay, so that being said, let's do another one that you guys have done before. What if I had 4 to the power of 7 over 4 to the power of 3? What would that be? That'd be 4 to the power of 4, right? You subtract those exponents. Okay, well that's the quotient of powers, right? It's saying the same thing. See how we're just dividing those and then you'd subtract those exponents? Okay, you guys have also done this one. Power of a power. So if I had 5 to the power of 2 times, or sorry, 5 to the power of 2 to the power of 5, what would that be? That would be 5 to the power of 10. Good. What did you do there? Multiplied. Yeah, so we multiply. So if we're going to power to a power, then we're going to multiply the exponents. Remembering that all of these things only hold true if the bases are the same. Okay. Now, power of a product. You guys did this too. We did this one in Math 9. So if we have, let's say, okay, so if we have, let's say, 3 times 4 to the power of 3, then that would be the same thing as 3 to the power of 3 and 4 to the power of 3. Like it distributes to both. It just means it's like both of those things to the power of 3. So you could write that out as 3 to the power of 3 times 4 to the power of 3. So that's what power of a product is talking about. Do you see how it was just like x times y to the power of m is the same thing as x to the power of m times y to the power of m. So just like the example I just gave you there. Same thing with quotient. If you're dividing, it would be so x over y to the power of m. So we're going to move that table back here one of these days. I think they've all moved forward. Yeah. Do you guys want? No, I turned it off for that. Okay. So where was I? Yeah. So if you're dividing, so x divided by y to the power of m is the same thing as x to the power of m divided by y to the power of m, right? Just applies to both again. We also did this one, right? We've done most of these, right? Like most of these are our review. Zero exponent. So anything to the power of 0 is 1, right? The only thing I'll add to that is just be careful because, let's do a couple examples. If I had negative 3 to the power of 0, what would that be?
-1.
No.
+1.
Positive 1, yeah. That'd be 1, right? Because anything to the power of 0 is 1. But what about this? What if I had negative 3 to the power of 0? What would that be?
-1.
Negative 1.
Yeah,
Negative 1. Because in this case, that negative was just kind of tacked on the front. This is like 3 to the power of 0. And then there was also just a negative on the front of it. The brackets matter, right? These brackets said anything inside those brackets is to the power of 0. Okay, which would just be the number 1. So just careful on those. Okay, and then negative exponents, we did that, right? That's what we did in the last lesson. And then fractional exponents, we just did that. So we've actually done all these things. Now what we're going to do is put them all together. We're going to have a whole bunch of things in one question. We have to try to simplify it all. So, you know, really gross things like that, right? We're going to simplify it down to something simple. So these are good examples. You guys can look back at these to kind of help you, but I think I'm just going to start into some of these questions. So let's do x to the power of 3 times x to the power of negative 2. All right, I'm going to show you guys this 2 different ways to show you that we could do this multiple ways. What is our rule if we are multiplying with the same base? What do we do with the exponents? If you add them. So we have to go 3 plus negative 2. 3 plus negative 2. That's the same thing as 3 minus 2, right? So that's going to be 1. That'd be the same thing as x to the power of 1. Or just x. So the other way I want to show you guys that this would work, let's do it another way. What if we just rewrote this x to the power of 2, or of negative 2? What do we do if you have a negative exponent? You flip it, right? So this would be the same thing as saying x to the power of 3 times, and then this was like x over 1 to the power of negative 2. That'd be the same as 1 over x to the 2. Because we're gonna be doing these things later on, like it will make it easier. Okay, so that would be the same thing as x to the 3 over x to the 2, and then what can we do there? X to the 3 over x to the 2. That's the minus. That'd be the same thing as x to the 1. Yeah. It does, I know, but we're gonna be doing other things where it might help. What's that? And different people do it different ways, so I want to make sure I show you guys all these, because there is no like one way to do these things. And the good thing about exponent laws is most of the time the order doesn't matter either. So like you can do them in whatever order. So everyone's going to have a different way of doing these things. Yeah. So I kind of want to give you guys just a few tools to get through it. Just while we're on it too, like I'm not going to take this long for every one of the questions. I just want to make sure we get through these things down. If you had x to the 3 over x to the 2, you can use the subtraction law, right? And say, okay, well, that's the same thing as 3 minus 2. That's the same thing as x. But the other way of looking at that was x to the 3 really means like x times x times x over, and x to the 2 means x times x. So if you just start canceling, right, then that just means 2 of those cancel with 2 of those. We're left with 1 on the top. So if I give you one more example here, what if we had like x to the power of 3 over x to the power of 5? So you can do your exponent laws, and I could say, okay, 3 minus 5 is negative 2, right? And that's fine, that's true. But I think more like visually, if you're trying to figure out what's actually happening here, this really means x times x times x over x times x times x times x times x. 3 of the ones on the top cancel with 3 of the ones on the bottom. That's the same thing as, well, all of the x's on the top are gone, but there would still always be a 1, right? It's not 0, it's 1. So that's going to be 1 over x to the 2, which is the same thing as x to the negative 2. Well, we have to be able to go back and forth. Like, this is a skill that we have to be able to do. So we have to be able to go like either way with that, right? And this one, right off the bat, like the way I picture it in my mind when I'm doing these things, and I think other kids do too, think about it this way. Think that you've got like a battle. You've got 5 x's on the bottom, you've got 3 x's on the top, and they're going to go to war. Well, how many are the x's on the bottom going to win by? They're going to have 2 left over after I cancel those ones out on the top, right?
Not if the 3's have a...
Then that would mean that you're going to have 1 over x to the 2 left over, right? If you do that. Okay. I'm just giving you guys a bunch of just ways to think about these, because like what I'm going to do here in a second isn't going to be the way. You guys are all going to get your own. So, okay, so let's do this one. So we've got x to the 2 times y to the negative 3 to the power of 4. Any ideas on how we could handle this one? Like we want to get rid of the exponent to an exponent, like that 4. And when we simplify these things, we don't want negatives in there too. We want to put them either to the bottom or to the top when we're done. So what would we do here first?
Combine x and y.
Well, you can't combine x and y. They're different variables, so they have to stay separate.
False.
Yep.
But you multiply the 4 by the 2 squared.
Yeah, yeah. You see, multiply the 4 by the 2 and the 4 by the negative 3. Remember that was that rule that was up at the beginning here. That was the power of a product, right? That was that one. Okay, so that would be the same thing as x to the power of 2 times 4 is 8. Y to the power of negative 3 times 4 is negative 12. All right, but I was saying when we say simplify, that means we don't want to have a negative exponent. Where will that, how could I rewrite this? This would be the same thing as flip it. And are you guys getting the hang of this where if it's y to the negative 12 and it's on the top, I'm just really going to move that to the bottom, right? Like I could write it as x to the 8 times 1 over y to the 12 and then multiply and everything else, right? But in the end, that's just that y is just going to be on the bottom after I'm done. So you can just say that's the same thing as x to the 8, and if it has a negative in the exponent, just flip it down to the bottom. So that would be over y to the 12. Okay, this one's pretty easy. Y to the, what would it be? 6. We add those, right? What would this one be? Y to the
8. 6.
I'm tricking you guys.
Y to the 2.
Do we have a rule for adding?
No.
No. Can't do it.
Do the 4 plus 2.
That's all we can do. You can't combine those. Those aren't like terms, you know? Like we could have, we'll get into that unit here in a bit too, but those aren't like terms. We can't really do anything with that. We just have to leave it as y squared plus y to the 2. Okay. You know what? Those were very similar to what we just did. I think you'll be okay on that one. Well, actually, you know what? Let's do this one. Okay. So let's go. Well, what would you guys do? Would you go 2 times both of those? And then simplify it? You can do that. I'll show you. It actually might be a little easier to simplify these guys first and then go to the power of 2. You'll get the same answer either way, but z to the power of 7 divided by z to the power of 3, that would be z to the power of 4, right? You subtract those, and that's still all now to the power of 2. So z to the power of 4 to the power of 2 would be z to the power of 8. We multiply when you go power to a power. Okay. And now we're just going to get harder. Okay, what would you do here? So we'd go negative 2 times that one, negative 2 times negative 5, right? We'll just pretty much... Well, actually, you know what? We'll do the same trick. We could do that. My bad. Let's combine these guys first. So we'll go, okay, well, on the inside there, that'd be the same thing as x to the power of... Now be careful, because we got a bunch of negatives, and we're adding negatives and everything else. So if you want to make sure we don't make a mistake here, write it out. We need to go negative 3 plus negative 5, which would be the same thing as negative 3 minus 5. So negative 3 minus 5 is now going to be at negative 8, right? You're at negative 3, and then you go 5 to the left. You're getting more negative. So negative 8 to the power of negative 2. And then this will all become x to the power of... Negative or positive? Yeah, negative times a negative gives me a positive, so this is going to be x to the power of 16. Okay. Let's do this one. So these ones look like they're more confusing, but really we just got to do it piece by piece. So I can only take care of the a's by themselves, the b's by themselves, and the c's by themselves. So let's just do the a's first. A to the power of 3 divided by a to the power of 2 would be a to the power of 1, right? Or just a. Okay, so we got that one down. B to the power of 4 divided by b to the power of negative 3. This one you should write out just until we get the hang of this. They're really saying here 4, the division sign means we subtract, so 4 minus negative 3. So positive 7, right? Minus a negative means that we're at 7. So that's going to be b to the power of 7. And then we've got negative 2 minus negative 4. So that would be the same thing as negative 2 minus a negative is like plus 4, so 2. So that'd be the same thing as c to the power of 2. All right. Okay, what I'm going to do here on this one, let's go, so we got a power to a power. Let's handle that one first. I could like apply this to both of those, but it's going to make my numbers a lot more confusing than they probably need to be right now. Let's just combine those. So this will be the same thing as negative 3 over 2 to the power of negative 4 times 2, negative 8. Okay, now this brings in from last lesson there. What does that negative exponent do? Flips them, right? So that's going to be the same thing as negative 2 over 3 to the power of now positive 8, because I just did the flip. All right, the negative already took care of the flip. Okay, and that's probably good. We can just leave it like that. You could also, if you wanted to, write it as negative 2 to the power of 8 over 3 to the power of 8. And then after that, you pretty much just have to put it in your calculator to figure out, you know, what some of those numbers are, because they're starting to get pretty big exponents, right? They're hard to do in our heads. Okay. Let's do this one. So we'll go, it's like the same question, isn't it, for the first part? So we've got, we'll do those ones first. We'll say that's the same thing as negative 3 over 2 to the power of negative 8. And I'll write the next one out here too while we're at it. So that'd be the same thing as negative 3 over 2 to the power of 6. And now that I have the same, like I could flip these ones, right? Like we did in the last one with the negative exponent. But it's actually set up really nice right now because I've got negative 3 over 2 and negative 3 over 2, right? Those are the same base. So what can we do with our exponents now? And just add them, right? So I can say, okay, let's keep that same base. Let's keep negative 3 over 2. And then to the power of negative 8 plus 6. Negative 2. All right, so that negative on the exponent, what is that going to do? That's going to flip our numbers. So we're going to have still negative 2 over 3 to the power of just 2. And we probably could do this one now. Well, first off, is our number going to come out positive or is it going to come out negative in the end? Are you positive?
Oh, no, negative.
No, it will be positive. I was just and the reason why it will is, look at, so I know it's a fraction, but that's like saying negative, I'll throw a different number in there, negative 2 to the power of 2. When you square a negative, it's going to come out positive, right? So I know my answer is coming out positive here, right? You could also think about it this way. If we broke this up, this would be the same thing as like negative 2 squared over 3 squared, right? If we applied the 2 to both of those. So the negative 2 is going to come out positive. Okay, so in the end, that's going to come out as 2 to the power of 2 is 4. 3 to the power of 2 is 9. So 4 over 9. Aren't these ones fun? They're just like a little puzzle. No. Okay, so we got decimals. Doesn't matter. They're the same base, right? So we can apply the same rules. Just one. It actually doesn't matter the order that you do. You could do these two first and then multiply. But I think I'm gonna want to do the top first. Let's combine those into one and then divide. So 1.4 to the power of 3 times 1.4 to the power of 4. That would be the same thing as 1.4 to the power of 7, right? And then that's still over 1.4 to the power of negative 2. Okay, what do we do when we divide? Subtract, right? So that's the same thing as 7 minus negative 2. So 7 minus negative 2 would be 9, right? That's like adding. It's like an addition sign there. So that would all just be 1.4 to the power of 9. Okay. And more. All right, everybody likes fractions, right? Okay, so we've got 7 to the power of 2 over 3 divided by 7 to the power of 1 over 3, yada, 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 right? So what I'm going to suggest we do is let's figure out the middle, all right? I'll do that exponent at the end, I think. So we won't worry about that. Now, like I said, we could do that one divided by that one first. We get the same answer. But I think, just for simplicity here, let's combine those first. Let's combine the bottom. So we'll just write everything the same, but we'll combine the bottom. So that's going to be 7 to the power of 2 over 3. Just writing that again. Over, and then we'll combine those. So that's going to be 7 to the power of, and I know they're fractions, but they're set up kind of nice already. What would that be? 7 to the power of? So you just add, yeah, so we're just going to add, so, right? So that you'd add the tops and you keep the bottom the same. That's going to be 6 over 3. Which would be 2, but I can actually see that my next step is going to be to subtract those same 2 fractions. I think I'm going to leave it that way because I already have a common denominator. Is my big head getting in the way again? Okay, so we'll leave it that way for a second, and that was all to the power of 6. Okay, and then let's do the next step. So we're going to take both of these. So 7 to the power of 2 over 3 divided by 7 to the power of 6 over 3 would be 7 to the power of negative 4 over 3. I'll write that a little different. 7 to the power of negative 4 over 3 to the power of 6. Okay. Now, we'll take those two. So we're multiplying. Multiplying is the easy one though, right? Multiplying is pretty straightforward. So, and again, if you need to, don't just like look at it and try to do it in your head. Write it out. So this would be the same thing as writing, here, I'm just going to do a little aside here. Negative 4 over 3 times, and then 6 is really like 6 over 1. You guys remember how to multiply fractions? That one's just straight across. So we're just going to go 4 times 6, or negative 4 times 6 is negative 24. 3 times 1 is 3. Okay, which is the same thing as negative 24 divided by 3. 8. Negative 8. Okay, so that's all the same thing now as 7 to the power of negative 8. How should we write that now, though? We don't want negative exponents. That would be the same thing as 1 over 7/8. Or maybe you would have went 1 over 7 to the power of 8. That's the same thing, though, right? Because 1 to the power of 8 is still 1. 7 to the power of 8 is, yeah. So either way there. Yeah. Yeah, this one will be a good one to do because, okay, so we've got 8 times a to the 3 times b to the 6, and then all of that is to the power of 1 over 3. Okay, we are going to apply that power of 1 over 3 to every one of those. But this is always a place where people make mistakes, is when we just go back to like actually basics here. Well, not basics because it's the power of 1 over 3, but we've got just the number 8 to the power of 3, of 1 over 3. What is 8 to the power of 1 over 3? Yeah, good. Yeah, awesome. Yeah. 8 to the power of 1 over 3 is the same thing as the cube root of 8. What is the cube root of 8? 2. 2 times 2 times 2 is 8. Right? So I can just write that as 2. 8 to the power of 1 over 3 is the same thing as 2. Okay? So it's combining that other, like we had like a whole lesson on that, right? So we're throwing that in the mix now. Okay, so now a to the power of 3 to the power of a third. Now we're going to be applying our exponent laws, right? That last one, we weren't applying exponent laws. We were just doing the cube root of 8. So now that's really saying, so 3 times a third. right? So let's just look at this. 3 times 1 over 3. So that's like 3 over 1, right? So now, again, multiplying is easy, one straight across, but I want you guys to start getting used to this idea too, that if I've got a 3 on the top there and I got a 3 on the bottom, I can cancel those. This is all just equal to 1, right? Because you got like 1 over 1 in the end there. Yeah? So this will be a to the power of 1. Or just a. You could write either one. Okay. 6 times a third. So 6 times a third. Can anybody just looking at that right now? 6 times 1 over 3. Without going across, without going 6 times 1 and 1 times 3. Can you guys see what that's going to end up being just from looking at it? Because we got to start getting good at this. Yeah. It's going to be 2. Right. Perfect. And what you can do there is we're really just going like 6 divided by 3 in the end. Right? Or, because you're just canceling the 3 and you just end up with a 2 left over there. If you don't like that way yet, just keep going the other way. But we're more and more we're going to be kind of canceling things like factors like that. Okay, so in the end, that's b to the power of 2. Okay. This one isn't actually much different than the other ones we've been doing, but sometimes it's written this way with the brackets, around both of those, and then the brackets around both of those. To tell you the truth, these brackets in this case are actually kind of meaningless. They aren't really doing anything here. Yeah, this would all be the same thing if those brackets weren't there at all, and those things are just multiplied by each other. But I can only multiply x terms together and y terms together, right? I can only combine those. So all we're going to do here is just look at the x's first and then the y's. So x to the power of 3 over 2 plus, we're going to add the exponents. So that will all just be x to the power of, not 1, 2. It's going to be in 2, right? Because we're going to go 3 over 2 plus 1 over 2. When you add fractions, that would be the same thing as 3 plus 1 is 4 over 2. 4 over 2 is 4 divided by 2. So that's 2. So that's all going to be x to the power of 2. Okay, so now our y to the power of 2 plus negative, sorry, I'm saying that wrong. Y to the power of 2 times y to the power of negative 1. We're going to add the exponents. So that would be like 2 plus negative 1, or 2 minus 1 is 1. So that's all just y to the power of 1, or just y. Yep. for the next ones. Okay. Okay. Different ways to do this. I think it's actually going to be the best to divide the middle, like take care of the middle first, and then we'll handle that power on the outside. So 100 divided, oh sorry, let's back up here. So when I do that, I'm just doing like piece by piece. And first off, I can just go my numbers divided by my numbers, right? Just leave the a and the b out of it for a second. 100 divided by 25 is 4, right? So my very first thing, it's gonna be 4. Okay. A minus a to the 5. That's going to be a to the power of, it won't be negative 5, negative 4. Yeah, because this is really like a to the 1, right? So we're going like 1 minus 5, right? When we divide, we're subtracting. So that's going to be negative 4. And then let's write this one a little different. That would be the same thing. Well, we could just leave it down there too if you want. Let's do it like that. It's in the bottom now. We can just leave it in the bottom. B to the power of a half. Are you guys okay with that move? It was already in the bottom. I just left it in the bottom. It would have also been true. I just don't write this down, but I could have also wrote 4 a to the negative 4 and then b to the negative a half, right? And left it in the top. That would have been fine. I could have done that too. Yeah? Okay. Just different ways of writing. So, and now that is all to the power of a half. Okay. Let's, I could take the square root of these things now too, but let's actually put this one where it goes. Like, I'll get rid of that negative now, just to show you that we could. We could have done it after, but I'm going to do it now. What can I do with that a to the power of -4 to get rid of the negative? Yeah, just down to the bottom. It's in the top, right? It just moves to the bottom now. I can just write it down there. So this will all be 4 over a to the 4, b to the 1/2. And that's all to the power of 1/2. Okay, now, question is, what is 4 to the power of 1/2? 2. How did you guys know that so easily? What is to the power of 1/2? That's the square root, right? 4 to the power of 1/2 is the same thing as the square root of 4. Right? Because that's base, or the index of 2. Okay. All right. So it's going to be 4 to the power of 1/2, so that's 2 over, and now a to the power of 4 times, well, sorry, a to the power of 4 to the power of 1/2 is 4 times 1/2. What is 4 times 1/2? 2. Right? Because that'd be like 4 over 1. That'd be 4 over 2, and then 2. Fractions. Okay, yeah. Okay, so that'd be the same thing as a to the power of 2. Now, b to the power of 1/2 to the power of 1/2, we're going to go 1/2 times 1/2. That's the same thing as 1 over... multiplying, we actually just go straight across, right? It's not a common denominator thing. It's going to be 1 times 1 is 1, 2 times 2 is 4. What's that? No, it's because it's a power to a power. Yeah, so we had to multiply those. Okay, so then that's b to the power of 1 over 4. All right. Another one. We're almost there, guys. So let's go. Again, just one at a time. So we're going to do numbers, and then the a's, and then the b's. So this first part's easy. You all got this? 4 divided by 2. 2. Same thing as 2. Okay, a to the power of -2 divided by a to the power of 2. We're really going -2 minus 2. -4. So just careful on those. A to the power of -4. And then we're going to subtract these exponents. So that's going to be 2 over 3 minus 1 over 3. 2 minus 1 is 1 over 3. So that's going to be b to the power of 1 over 3. Good? You guys are looking at me funny like I did that wrong. Okay. The question was, how do you know when to stop? Like, is this good enough to stop? And it's actually not. So I want to combine them into just one b if I can, right? There was 2 b's there, 2 a's, there was 2 numbers. Like, I'd like those to be 1, so we're simplifying it. And then the other part of it is we don't want any negatives in the exponents when we simplify. So the very last thing we're going to do here, well, is what? How do we handle that -4? It just gets put down to the bottom. So in the end here, we're still going to have the 2 times b to the power of 1/3 divided by a to the power of 4. And then that's it, right? There's one number, one a, one b, right? So it's as simple as it can be there. Let's do this one quick. This one won't take very long. So it says the volume v of a sphere with a radius r is given by the formula v is equal to 4/3 pi r cubed. And then it tells you what v is, and we're supposed to solve for r. Okay, this one doesn't really fit with the other questions as much. It's more just straight up algebra. But the way we do this is, here, I'm just going to write down the equation again. So that'd be v is equal to 4/3 pi r cubed. Now, they've given us the volume. So instead of a v, I'm actually going to just throw in 425, because that's what the volume is. So 425 is equal to 4/3 pi r cubed. Okay. Now, I'm just going to get this ready. Okay, so then what we're going to do, I'm going to get rid of just piece by piece. So right now I've got like a 3 in the denominator there. It's like I'm dividing by 3. So when we're doing algebra, we always do the opposite. So what am I going to do on both sides? I'm going to multiply both sides by 3. So I'm going to go like times 3 and times 3. So those cancel, right? 3 over 3 is 1, so that just cancels with each other. And we end up with 3 times 425. So we get 1,275 is equal to 4 pi r cubed. Now, I could just divide by 4 and then divide by pi again. I'm going to take them all at once though. Let's take these as a chunk. I'm going to divide by 4 pi and then divide by 4 pi. With a caution. Because if you guys put this in your calculator, so I know like a lot of people will end up getting this one wrong at this point. And the reason for that is because you should have that in brackets in the bottom when it goes into your calculator, if you're doing it all in one move. Because if you typed in 1,275 divided by 4 times pi, what your calculator thinks you mean is 1,275 divided by 4 times pi. Right? It didn't know that the pi was actually supposed to be down there. So in order to tell my calculator, no, it's supposed to be in the denominator, we put brackets around it so that it's dividing by all of that. So just make sure that you don't make that common mistake. Okay, so what is that? So we've got 1275 divided by... Okay, so we end up getting 101.46 is equal to r cubed. And then what's the very last thing we do? If r cubed is equal to that, we're going to cube root it. Yeah, good. Cube root both sides. So we get the cube root of that is 4.66 is equal to r. So yeah, good enough. So 4.7.